If Cisco ACI has ever felt like a pile of abstract objects with confusing names, that's usually because the hierarchy hasn't clicked yet. Once you can see how tenant, VRF, bridge domain, application profile, and EPG fit together, the model stops feeling arbitrary. Think of this video as a map, not a vocabulary quiz. We'll keep coming back to one three-tier application so every object has a job, a place, and a relationship you can picture. By the end, you'll be able to read the full ACI policy hierarchy and explain why each object exists in real design terms. Let's start higher up. ACI is not asking you to memorize nouns for the sake of it. It's asking you to describe how an application should be organized and connected. In a traditional network, you often think box by box, interface by interface, and VLAN by VLAN. ACI starts with intent, then defines logical objects for segmentation, addressing, and policy. That is why the object model matters. It is the language APIC uses to turn application intent into fabric behavior. A good mental shortcut is this. The policy model is a map of scope, forwarding, endpoints, and policy. Some objects define where things live, some define how traffic is forwarded, some define which groups are allowed to talk. So instead of treating tenant, VRF, bridge domain, application profile, and EPG as separate trivia terms, read them as connected layers. And as we build the stack, keep asking one question. What design problem does this object solve? Now we can build the foundation from the top down, starting with the tenant. A tenant is your top-level administrative and policy container. It gives you a clean scope to group application objects together. In real life, a tenant might represent a business unit, an environment, or a customer. What matters is isolation of policy context, not a magic one-size-fits-all meaning. Inside the tenant, the next major object is the VRF. The VRF defines a layer 3 routing domain. Endpoints in different VRFs are separated at the routing table level unless you deliberately connect them. That means the VRF answers a different question from the tenant. The tenant is scope and ownership. The VRF is layer 3 reachability. Then we get to the bridge domain, which is where many people start mixing concepts. A bridge domain is the layer 2 forwarding domain tied to a VRF. It defines a subnet and flooding behavior context for endpoints living in that segment. So if you want the simple stack, it goes like this. Tenant contains policy scope, VRF contains layer 3 routing context, bridge domain contains layer 2 and subnet context. A bridge domain is not the same thing as an EPG, and it is not just a prettier name for a VLAN. You can have one or more EPGs associated with the same bridge domain when those endpoint groups share the same layer 2 and layer 3 context but need different policy treatment. That distinction is huge because it shows ACI separates forwarding context from policy grouping. Once that clicks, the rest of the model gets much easier. With the forwarding foundation in place, we can move to the application-facing side of the model. The application profile is mainly an organizational object. It groups the endpoint groups that belong to a specific application view. It helps structure the policy model around an application, but it is not where forwarding decisions live. The really important object here is the EPG or endpoint group. An EPG is a logical group of endpoints that should receive the same policy treatment. That is the key idea to hold on to. In a legacy mindset, engineers often try to map one VLAN to one application segment and stop there. ACI can map EPGs to VLAN-backed domains at the edge, but an EPG itself is not just a VLAN label. It is a policy identity for a set of endpoints. That means two endpoint groups can live in the same bridge domain yet still be separated by policy because policy follows the EPG, not only the subnet. For a three-tier app, web servers can be one EPG, app servers another, and database servers a third, even when the overall design is part of one application. Now the model starts to feel application-centric instead of network-centric. Instead of asking only which VLAN an endpoint belongs to, ACI wants you to ask which policy group it belongs to and which other groups it should reach. That is why EPGs are so central. They are where the application model becomes enforceable network policy. At this point, let's zoom out and rebuild the whole stack in one view. Begin with the tenant, your main policy container. Inside is the VRF for routing. Below, bridge domains define subnets for endpoints. In parallel, the application profile structures the app view, grouping endpoints by policy. Here's the subtle but essential part. The hierarchy shows containment, but the design also depends on relationships across those layers. An EPG does not replace the bridge domain. It attaches to that forwarding context while carrying its own policy identity. So when you read the model, think in two tracks at once. One track is where objects are contained. The other is how traffic and policy are related. That is the mental model I want you to keep repeating. Scope, routing, subnet, application grouping, policy grouping. If that stack is clear in your head, ACI object names stop being random and start describing design choices. Now let's apply that stack to a real three-tier application so each layer becomes concrete. Let's make this real with a classic three-tier application that has web, app, and database tiers. First, create a tenant for the application environment you want to manage as one policy scope. Inside that tenant, choose a VRF that represents the routing domain for this application stack. If these tiers should route to each other as part of one application domain, keeping them in one VRF is often the clean starting point. Next, define bridge domains for the subnet context you need. In many designs, web, app, and database tiers each get their own layer 2 segment and subnet. Now create an application profile to organize the application-facing objects for this service. Within that application profile, create 3 EPGs, one for web servers, one for app servers, and one for database servers. Each EPG is then associated with the appropriate bridge domain so the endpoints have the right forwarding context. This is where the model starts to feel elegant. Bridge domains answer where endpoints live. EPGs answer how those endpoints are treated. From there, policy is expressed between EPGs, not by sprinkling access lists across random boxes. The web EPG might be allowed to consume a service from the app EPG. The app EPG might be allowed to consume database access from the database EPG. In practical design terms, that means you model communication by application role, not just by IP subnet. If the database tier should never talk directly to the web tier, that becomes a policy relationship between EPGs. And if multiple endpoint groups need the same subnet context but different security posture, you can keep the forwarding context shared while separating policy at the EPG level. So our running example ends up reading like a sentence. Tenant contains the app environment. VRF defines routing. Bridge domains define segment context. Application profile organizes the app. EPGs express policy roles. Let's compress the whole model into something you can actually remember under pressure. Tenant gives you the top-level scope for a set of related application objects. VRF gives you the layer 3 routing context. Bridge domain gives you the layer 2 and subnet context where endpoints live. Application profile organizes the application view. EPG groups endpoints by shared policy intent and becomes the main unit for expressing who should talk to whom. So the big takeaway is simple. ACS object model is a hierarchy of design roles, not a random list of labels. Once you can read tenant, VRF, bridge domain, application profile, and EPG as connected layers, real application designs become much easier to reason about. And the natural next step is contracts and policy enforcement, because that is where these endpoint groups turn into allowed communication. Now that the example is on screen, let's talk about the mistakes that usually make ACI feel harder than it is. So that's the mental map for ACI. The tenant holds the overall policy context, the VRF defines the layer 3 boundary, the bridge domain handles layer 2 behavior, the application profile groups the app's intent, and the EPG is where workloads are actually organized and matched to policy. Once that structure clicks, the next logical step is seeing how those groups talk to each other. That's where contracts and policy enforcement come in, and that's exactly where we'll go next.